So now that we've talked about how to implement a custom subclass or a custom structured task scope subclass, let's go ahead and see how we can actually use this in practice. And this example will show how to implement a custom structured task scope, which we call shutdown on non-null success. And it'll also compare that technique to the approach of using shutdown on success with exceptions. And you can decide which one you like better. So this particular example can be found in my ex5 project in the Loom folder in my live lessons GitHub repository. So we're now in the ex5 project in my Loom folder in my live lessons GitHub repository, and we're going to take a look at the code for this example. This example starts out with a list of large numbers, large long numbers, both prime and non-prime. Basically, all the even numbers are, of course, not prime, and all the odd numbers are prime. And I used a prime number generator to generate prime numbers, so I know that we've got prime numbers in this list. And then we've got a little test program here, and we're going to demonstrate two different implementations in two different ways. And we're going to call these methods demo shutdown on success and demo custom structured task scope. So those are the two things that we're going to demonstrate. And you'll notice that in both cases, we're going to pass in all the numbers for the first go round. So there will be prime numbers to be found. And then in the second case, we're going to pass in the numbers, removing the odd numbers. So there will not be any prime numbers because, of course, even numbers can't be prime. So let's take a quick look at remove odd numbers just for kicks. This is just a simple little method that converts the list that's passed to it into a stream, keeps only the even numbers, and then converts that stream of even numbers back into a list. Just a little helper method. I should probably put that in a library somewhere because I can use it other places. So let's go ahead and take a look at demo shutdown on success first. So this is going to show the implementation of this algorithm using the structured task scope shutdown on success variant. And you can see that we make a new try with resources block that makes one of these guys parameterized with long, because of course we want the result to come back as a long. We then take the numbers that are passed in, which again are either going to be prime and non-prime or just non-prime. And then for each number, we're going to go ahead and fork off a task. It's going to be a virtual thread, of course, and we're going to check to see if the number is prime. If the number is prime, we return the number. That will cause the shutdown on success to stash away that result in its little future field and then shut all the other threads down. So it'll shut it down on the first successful result. Otherwise, we're going to throw an exception. And I just throw the no such element exception. That's probably a goofy exception to throw. I should make my own, not prime exception or something like that. But what'll happen in that case, as we saw when we looked at the implementation, is that that's not a successful completion of that future. It's a failure. And so as a result, that will not shut down the shutdown on success scope. So that'll keep going. And then you can see here, we're going to keep going. And when we're either gone through all the items or we're done, we go ahead and call the join method, and then we grab the result, which is either going to be a valid result of the first prime number that finished, or when we go to get the result, an exception will be generated, in which case we'll transition over here to this exception block where we're going to print out no prime results found and give the message of the exception, which in this case is going to say no such element exception. So that's what we're going to do for this particular case. So what we're going to do now is we're going to take a look at the implementation of demo custom structured task scope. And this works very similar to before. However, what it's doing is it's creating a new shutdown on non-null success object, which of course is a subclass of structured task scope. And what that's going to do is it's going to only only shut everything down when the first non-null result occurs. And if there is no non-null result, then it'll return null when we're all done. So here's what it does. We go through the list of numbers. For each number in that list, we fork off a new virtual thread. We check to see if the number is prime. If it is prime, we return the number, which is going to trigger a shutdown. Otherwise, we return null, which is not going to trigger a shutdown. It's just going to say, well, we didn't get what we wanted. Keep going. And when we're all done, we're going to go ahead and call join. That'll wait for either the first of these elements to finish successfully or for them all to finish unsuccessfully. We then go ahead and get the result. And if the result is non-null, we found our first prime result. Otherwise, no prime results were found. So the first thing to notice is there's no exceptions here, no exceptions being thrown here, and there's no exception handling being used here. So now let's take a quick look to see how we implement that custom variant of structured task scope. You can see that shutdown on non-null success extends structured task scope, defines this volatile field that keeps track of the result. Its constructor makes an unnamed element that will, an unnamed scope that will use virtual threads. And then its handle complete method, when called, will take a look at the future, which should be completed. And assuming that the state of the future is not running, we then check to see if the state of the future is success. If the state of the future is success, we take a look at the result of the future. And if that result is non-null, then we found our first successful result. So we stash that into mResult, which is the field, and then we return, or we shut everything down and then we bail out. So all the other threads have been shut down. But if it was null, we don't do that. We just ignore it. And then here's the method called result that just returns the result. So we get the result back from this, and we can use that in order to be able to tell the client what the result of all these things were. So hopefully that gives you a good idea of both how to use shutdown on success with exception handling to skip over things that are not successful, which then incurs some of the heavyweightiness of exceptions. Or you could use your own custom class shutdown on non-null success, or whatever you might want to call it, shutdown on match or whatnot, which can kind of be a little more streamlined, but it requires you to understand how to subclass and extend from the framework. So that's the end of that case study example.